The mystery that has been surrounding the Milky Way for so long has been finally solved. The Event Horizon Telescope team unveiled the first image of Sagittarius A, which is a supermassive black hole located at the center of the Milky Way and is roughly 26,000 light-years from Earth. There were about 300 researchers involved from 80 different institutions. In April 2019, researchers took the first picture ever taken of a black hole, M87, in a galaxy far, far away. The supermassive black hole known as Sagittarius A is our very own personal black hole, and it serves as the pivot point around which our galaxy spins. For a long time, scientists assumed that the strange events that take place in our galaxy's chaotic center could only be explained by the presence of a supermassive black hole at its center, where enormous stars bounce around an invisible object at a significant fraction of the speed of light. However, they have been reticent to come right out and say it. For example, the Royal Swedish Academy of Sciences decided to split the 2020 Nobel Prize in Physics between Roger Penrose, Reinhard Genzel and Andrea Ghez for their contributions to unraveling the mysteries of black holes. Reinhard Genzel and Andrea Ghez discovered that the star's orbit around the center of the Milky Way is controlled by an entity that is both unseen and incredibly hefty. This enormously heavy object has a mass that is equivalent to 4 million suns' worth of solar masses and is packed into an area that is roughly the size of our solar system. The conclusion that can be drawn from their research is that the Milky Way has an undiscovered supermassive object at its center, and that the existence of a black hole is the most likely explanation for this phenomenon. Since more than half a century ago, physicists have entertained the idea that our galaxy's galactic core might be home to a mysterious black hole. A black hole is the result of the collapse of a star, which creates a region in the universe with an escape velocity. This is the speed at which an item must move to overcome the gravitational force of a planet or another object. Since there is nowhere for light to go, black holes are invisible and can only be observed using specialized equipment and telescopes that are designed for space. The reason why there is no way for the light to go out is that the gravity within a black hole is extremely powerful. As a result of a large amount of mass is compressed into a relatively tiny area. However, they distort the space-time around them to such an extreme degree that when illuminated by blazing streams of infalling matter that is shredded in their gravitational grip, they cast a shadow. This shadow is approximately 2.5 times larger than a black hole's event horizon, which is the border of a black hole as well as its defining feature. This line in space-time is the point at which nothing that passes through it can ever return. A method known as very long baseline interferometry, which combines radio observatories on multiple continents to form a virtual Earth-sized telescope, is used by the EHT to capture images of this shadow. This method boasts the highest resolution of any instrument used in the field of astronomy. In April 2017, members of the EHT collaboration worked through several nights directing that virtual instrument towards Sagittarius A and other supermassive black holes. During the same mission, the scientists also obtained the raw data necessary to create an image of Sagittarius A, but the process of transforming those observations into a picture took a great deal of time. This is because Sagittarius A is in a state of continual change. The supermassive black hole in the center of the galaxy Messier 87, sometimes known as M87, is so massive that it requires a great deal of time for the material that orbits it to complete a full cycle. That means that you can stare at it for an extended period, and there will be very little change in its appearance. Since Sagittarius A is almost 1,000 times less massive than Sagittarius M, the rate at which it changes is approximately 1,000 times faster. This is because matter moves in tighter and more rapid orbits around the black hole. This photograph gives evidence that the object that has been the topic of conjecture for decades at the center of the Milky Way is a black hole. The distance between Earth and the black hole is so great that when astronomers looked up at the sky, the black hole appeared to be about the same size as a donut that is located on the moon. After building the Event Horizon telescope, the team monitored Sagittarius A for several nights, collecting data in a manner analogous to a long-exposure photograph. In a statement that was made public by EHT, the organization expressed its excitement that scientists now had photos of two black holes that are of extremely different sizes, which affords the potential to grasp how they compare and contrast with one another. Alright guys, that's a wrap for this video. Thanks for watching. If you enjoyed the video, consider leaving a like and subscribing to the channel for more videos just like this. See you guys next time.